Hello again, and welcome to the fourth section of this course, creating a classifier. Before we dive in and start creating our classifier, let's first talk about machine learning. We are all familiar with various types of software and application we use daily. Those are programmed to perform a certain set of instructions. Those instructions explicitly control the behavior of the program. Machine learning, on the other hand, is a science with a purpose of getting computers, programs, or software, if you would like, to act without being explicitly programmed. The basic mechanics of machine learning is to build algorithms that are capable of receiving input data and predict an outcome or output to control or define a program's behavior. The prediction becomes more accurate as the program executes because the algorithm is always updating itself as new input data becomes available, thus learning. In the past years, machine learning have given us effective web search, self-driving cars, enhanced online shopping or online shopping recommendations, and also fraud detection. Those are only few examples where we use machine learning nowadays. The process of machine learning starts with data, or what we called before in the previous section as dataset. Actually, the hardest problem is getting the right data in the right format. The dataset should always be related to the problem you are trying to solve or predict. So it's logical to think that pictures of lakes won't really help if you're trying to build an OCR system. OCR stands for Optical Character Recognition, and it helps us to easily take a picture of what someone else wrote on a board and convert it to text, like when you are scanning a document, for example, and want to convert it to a Word document. The dataset, once you have the correct one and you pre-processed it to a format that would serve your purpose, would be used as input to train your machine learning model or algorithm, which is a mathematical representation of the prediction process. So your model will learn from the provided data by analyzing it to figure out patterns that control the output or the outcome from your input. For example, a dataset with thousands of images with one solid color, where your model will learn what makes a picture blue, red, or green, based on its features like pixels. Then, once the training process is done and the model is ready, you can input a picture or input data in a more generic scenario and let your model predict its color for you. Now let's talk about some of the applications of machine learning. If you have used Facebook before, once you open the app or website on a browser, the newsfeed you see is generated using machine learning to make it personalized for every member. If you tend to read or like posts from a particular person or a page like a product page, then this behavior is analyzed, fed into the algorithm to identify the pattern and show you more relevant content based on what you like, commented on, or shared. Another area where machine learning is widely used is self-driving cars. That might turn human drivers obsolete. Hopefully not, because some people like to go on road and just drive away. We don't want to take that away from them. But it's real, not a science fiction movie anymore. A car can use complex algorithms to figure out its own way and avoid colliding with other cars or vehicles on the road. And avoid colliding with other cars or vehicles on the road. And also, nowadays if you have a phone, most probably it has a VPA or a virtual person assistant like Siri, Alexa, or Bixby. They can help you find information, ask about the weather, set alarms, and lots of various tasks. And this interactions is done by speaking to your virtual assistant, which means by talking to them same way you would talk to a human, but they're still not that capable of having a fluent conversation yet. Email spams. It's also one of the applications where we use machine learning by combining it with natural language processing. It can help us predict if an email is spam or not, to help you avoid spammers sending emails about their products, insane offers, or asking you to click on a link. Well, if you have been asked and you don't know the sender, just don't click. Also, you might notice that some websites recently started offering chatbots to boost the speed of their support. Well, now websites can pay people to respond to every query their customers might have. They use bots that tend to extract information from the user query and provide responses. If we talk about all the areas where we use machine learning currently to solve some problems, it will take more time. So let's move on and check out machine learning methods. Those methods are categorized as supervised and unsupervised methods. A supervised method uses data that it has learned in the past and apply what it has learned on new data. It starts from a dataset, gets trained, and produces a model to predict the outcome for future events. It can also compare the output if it's correct or not and modify itself or adapt to continue improving. On the other hand, we use unsupervised methods if the dataset is not labeled, classified, or categorized. Unsupervised learning studies the system and produces a function to describe a hidden pattern or structured from unlabeled data based on similarities. There are lots of algorithms we can use with machine learning, so let's check out some of them. Let's start with linear regression. It's a statistical approach to identify the relationship between variables. It predicts an outcome from an input based on the relationship between the variables extracted or obtained from the dataset. Logistical regression is also a statistical method used to predict binary outcome, 1 or 0, yes or no, a true or false, given a set of independent variables. Logistic is a special case of linear regression when the outcome variable is categorical. Like, for example, if you want to predict a transaction to be fraudulent or not, or an email if it's spam or not. Decision tree is one of the simplest and most useful machine learning structures. As the name suggests, it's a tree of decisions. It's mostly used for classification problems. We pick the most significant attributes to differentiate between groups in the data and split them. We continue to build a tree-like structure. Naive Bayes. A naive Bayes model is easy to build and very useful for large datasets. It's known to outperform even highly sophisticated classification methods. It's based on Bayes' theorem. Naive Bayes classifiers form a family of simple probabilistic classifiers. It assumes that all the attributes of a data under consideration are independent. For example, a classifier for fruits would know that an orange is round, a certain size, and orange, the color, but would not assume these things at once. There are other algorithms that can be used to train a model, like KNN or K nearest neighbor, K-means, random forests, or dimensionally reduction algorithms.